So continuing from the previous video, so I had phenol plus base mixture. To that I'm going to add NaOH, shake it well. I'm going to get an aqueous layer and an ether layer. Aqueous layer will have the salt of phenol and ether layer will have our base. So to the ether layer, because it will have a little bit of aqueous component, I have to remove the water which is adhering. So I'll be adding anhydrous sodium carbonate and then I'm going to filter that to get pure ether, and then I'm going to recover ether or evaporate ether to get back my base. So it's a separation of phenol plus base using solvent extraction method. So see here I have used NaOH and then done this. Hence, if you remember, we had discussed different types of extractions. We have basic extraction, acidic extraction, inert solvent, chelating or ionic extraction. Here for today I am showing you basic extraction. Okay. So to the mixture I am going to add 5% NaOH. So you have to observe there are particles. There are particles which are not dissolved in aniline. Okay, that is our phenol. We are supposed to actually wear protection equipments. Pardon me, I am not doing that. But when you perform it, you have to use PPEs in chemistry laboratory, because you know chemistry laboratory is all about observation. So when you have to observe, you have to have good eyes, nose, and your all sense organs should be present well and in nice condition. Okay, so now let us use one sense organ to just see, our eyes. So check here, I've added 5% NaOH and all the base has dissolved. All the base has dissolved. I mean phenol has dissolved. Base is insoluble. Okay, I have an aqueous layer and aniline here. I have to do solvent extraction. Okay, I want to extract the globules of aniline which is visible there, and I need even the aqueous layer. For that I am going to use a separatory funnel. So it's a separatory funnel. Okay, it should have a retort stand, but for a separatory funnel of this size I do not have a retort stand, so I am using a tripod stand. Kindly pardon me. So separatory funnel, and we are supposed to grease the stopper, and I have used vacuum grease here. I have already greased it, and now we shall add our compound into this. A compound into this. I am using a funnel, so I am going to add it here. Compound mixture. So as I pour, you can see there are 2 layers, no solid will remain. Okay, so see, solid is not remaining here. It's all an emulsion. Fine. To this I am supposed to add petroleum ether. So this is immiscible in aqueous layer. So we know solvent extraction needs 2 immiscible liquids. I shall take it and then I am going to add it to this separatory funnel. So you can see, before addition of petroleum ether it is like this. I am going to add petroleum ether to this. See, I have added petroleum ether. I am supposed to shake it. I shall shake it slowly and we shall see what's going to happen. So we have a clear separation here. Okay. So now we can drain this bottom layer. I have drained. So this is our phenol and this is our base. So we have to recover ether or we have to evaporate it so that we are going to get our base. So how do you know if this is a phenol? So we have seen ROH plus NaOH gave us the salt, RO minus Na plus. To this, if I add concentrated HCl, I am supposed to get back phenol and sodium chloride salt. Okay, so I am supposed to add few drops of concentrated HCl and I will get back my phenol compound. So I just need to neutralize it. See, as I go on neutralizing, I'm going to get back phenol. So this can be filtered and it can be used. So we have separated it and we can even analyze the given compound. So this one I've just got to evaporate ether. I get back aniline. So this is how we use solvent extraction for solid liquid mixture. I have shown you today solid liquid mixture under basic conditions. Similarly, you can use solid these extractions, that is solid. So we can use these extractions. Previously we have seen in our videos, you can extract metal ions by chelation or metal ions by using larger ions or metal ions by solvation or metal ions by ion pair formation. We can even carry out synergistic extraction, that is use both the methods, or we can even do extraction by using macromolecules. Okay, that is crown ethers, cryptands, etc. You can use and you can do solvent extraction method. This was just a simple illustration of how you can do solvent extraction for separation, identification, and as well as quantitative as well as qualitative estimation.